Alright, hi guys. We are going to start off this section of revision leading up to the exam, focusing on some of the things I think that you've probably done less well on throughout the year. So we're starting right off with something that I think we didn't kind of master ever, and that's expanding brackets and collecting like terms. So, expanding brackets is much easier than what you think it is, as long as you get the rule right, as long as you do lots of practice so you consolidate that skill straight away. Okay, so when we're talking about expanding brackets, what we're really doing is we're multiplying. Hang on, I'm just going to get my pen to work. Oh, it's been very slow. Yeah, just that. Okay, there we go. So when we're talking about expanding brackets, oh, now it's just disappeared. There we go. What I might need to do is I'll just pause this and I'll come back when it's working. Hang on. Alrighty, we're back on. So I've completely forgotten where I was saying. So expanding brackets, again, is really important. It's just a skill that you have to get right, and it just involves a bit of practice. Now, what we're really talking about when we're expanding brackets is we are multiplying an algebraic... Oh, gosh, I haven't spelled that well. Algebraic expression by something else. Now, when I say something else, something else means it could be another algebraic expression. It could be a number. It could be another letter. Okay, so you could be multiplying it by anything, and we'll look at examples of all of these. Remembering that an algebraic expression is just it's just a term that has some algebra in it where there's no equal sign. So for example, if we look at this first one here, x plus 3, that is an algebraic expression, and we're multiplying that by the number 2. Okay, so if we're thinking about this in a different way, if we're multiplying that by 2, we're saying we have 2 lots of x plus 3. Okay, same as if we times 2 by 2, that means we have 2 lots of 2. Okay, if we have 2 lots of x plus 3, then we have 2 lots of x plus 3. Yeah, we have x plus 3, one lot of x plus 3, and another one. And we can put that together to work out what that would be in a simplified form altogether. And we can see here we have 2 lots of x plus 6. Now, we could do that for everything, but it would be really annoying. And when it comes up to having letters instead of numbers, then that means we can't use that as a technique anymore. So we need to have a different way of doing it. And the way that we expand brackets, when we're talking about expanding brackets as a way of multiplying an algebraic term by something else, what you're doing is you're multiplying whatever is outside the bracket by whatever is inside the bracket. Now that means that you need to multiply both parts of the expression. And I want you to do this by drawing an arrow to everything that you're multiplying. Okay, so if we're timesing everything by 2, we first times the x by 2, and we get 2x. Then we times, the plus stays the same, because that doesn't change, there's no change of sign, so we still have a plus there. And then we multiply the 2 by the 3, which gives us 6. And you can see there we get the same answer in both cases. But this way is just a little bit quicker and easier. It doesn't involve collecting any like terms at the end like we did here. Okay, if we look at this second one, in this case we've got 2 lots of expansions that we need to do. And then we're going to collect our like terms and simplify at the end. So the first thing we do is multiply x by 3, which gives me 3x. And then we multiply 3 by 4. Again, that plus stays the same, and 3 times 4 gives me 12. Okay, then I'm going to multiply. Now this is minus 2. So in this case, we're multiplying everything by negative 2. So negative 2 times x is minus 2x. Okay, negative 2 lots of x. Negative 2 times by negative 1. We know that a negative times a negative is a positive, so that's going to be plus. And 2 times 1 is 2. Okay, we can then simplify. 3x minus 2x, well that's just going to be 1x. Remembering that we don't ever write the 1 in algebra, we just put x. So that's from 3x minus 2x. And if you want to do it off to the side, you can. And if you also want to like highlight or circle your like terms, you can do that as well, remembering that that negative is with the 2 because that's what's in front of it. Okay, then we can work out the second part. So then we have 12 plus another 2, so that's 14. So this whole sum altogether, when we simplify it, we end up with x plus 14. Third one down, we've got a lots of a plus b. So again, in this case, we couldn't have done this in terms of writing it out, which is not a very effective way of multiplying algebraically anyway. But we're doing the same thing again. So first thing we got is a times a. Now anything times it by itself is squared. So a times a, I'm just going to write it underneath, is equal to a squared. And then a times b, remembering that when we're writing in algebra, again, we write usually the first thing in the alphabet first, so ab, and then we just write that without the multiplication sign in the middle, and we can just say that's ab on the end there. Okay, next one here. With the last couple, last 3 or so, if you want to pause this, have a go at them yourselves, and then move on, go for it. If you don't want to, that's fine. So this next one, we've got x times x. Now that's x squared. Okay, anything times by itself is squared. Then we have x times negative y. So we've got negative xy. All right. Then here we've got y times x. Now remembering that again, we write the first letter of the alphabet first. So I'm going to write the x first and then the y. And that's xy. And we can write it however we want because 3 times 2, which is 6, is the same as 2 times 3, which is 6. So whenever you're multiplying 2 things together, it doesn't really matter which way you want to write it. But try and write it the first letter of the alphabet first, and then we can see here that these are like terms, and that's a bit easier. All right. Then we have y times y again, and that's going to be y squared. So now we can simplify this. So if we have these are like terms, because they have the same letters and the same amount of both letters. And if we have negative 1 xy, because remembering there is a little imaginary 1 in there that you can't see in both of those. If we have 1 xy, negative 1 xy, plus 1 xy, well, negative 1 plus 1 is 0, because that's the same as 1 minus 1, so 0. So these actually cancel out. They cancel each other out, and we go back to having 0 lots of xy. And then we have x squared plus y squared. And that's our final answer. All right, if we look at the next one, we've got 7x times by x. Now, again, we're multiplying all of this by 7x. Now, if there was a number in the front here, you would times the 7 and the number there is a number in the front there. There's really a 1, so we'll write the 1 in. So 7 times 1 is 7. X times x, we know that that's x squared. And then for the second part, we have 7 times 5, that's 35. Now there's nothing there to really multiply the x with, so we just chuck the x on the end. So it's 7x squared plus 35x, because again, you're multiplying that whole 7x by 5. You've got 5 lots of 7x, so that's 35 lots of x. All right, last one. Now I just put this one in here because you should see that this works with multiple terms. So you don't really need to, quite a lot of the times you'll only see 2 things in the bracket, but it doesn't actually matter how many things you have in the bracket. It's the same principle. So in this case, we'd have 2 times 3x, which is 6x, 2 times 8, which is 16, and then lastly, 2 times c, which is plus 2c. All right, there we go. Lovely. Okay, so that's a little bit of a revision on expanding brackets and collecting like terms. Have a go at the revision sheet attached, and I hope this has been helpful. If you'd like more examples, please let me know, and I'll send some through to you however you would like. Okay, all right, thanks very much. Have a really nice long weekend.